In this presentation, we're going to look at a discrete random variable exercise. So suppose we're given x, this random variable x, with the following information. The expected value of x squared is 3.6. The probability of x equal to 2 is 0.6. The probability of x equal to 3 is 0.1. And we're given some more information. The random variable x takes just one other value besides 2 and 3. This value is greater than 0. What is this value? The second question is, what is the variance of x? So first off, we have to find this other value. So to determine the missing value, let's call it k. And what we're going to do is determine the probability of that value. So we know that the expected value of x squared is 3.6. So we're going to use the approach for computing the expected value of x squared as our to find what k is, the missing value. So we have three values, xi. The three values are 2, 3, and k. Now we're going to square those values, so we have 4, 9, and k squared. That's the second row of that table. And what we're going to do is look at the probabilities for each of those outcomes. So the probability of 2 is 0.6. The probability of 3 is 0.1. Now we have to find out what the probability of k is. But if we look at this here, that 0.7 and 0.1, that 0.6 and 0.1, that gives us 0.7. So necessarily the probability of k has to be 0.3. Okay, so the probability of this missing value is 0.3, so that's a start. Now what we're going to do is consider how to compute the expected value of x squared. So we're going to use all this information here. So for each squared value, what we're going to do is multiply it by its probability and then sum them all up. So we have 4 times 0.6, so the square of 2 times the probability of 2. 9 by 0.1, so the square of 3 times the probability of 3, and k squared times 0.3, the square of k times the probability of k. And if we add all those numbers together, we get 3.6. Okay, so this will help us find out what k is. Now, so 2.4 plus 0.9 plus 0.3 times k squared, that gives us 3.6. So if we add those two numbers together, 2.4 and 0.9, we get 3.3 plus 0.3 times k squared equals 3.6. So what we're going to do is subtract 3.3 from both sides. And we have 0.3 k squared equals 0.3. So k squared equals to 1. And therefore k is equal to 1. Just recall earlier on I said that the value was greater than 0. Okay, so that excludes the possibility of minus 1 there. So k, the missing value is minus 1, or is 1. So we have answered the first question, what is the missing value? K is 1. Now let's look at the second question here. Compute the variance of x. Okay, this is what we're going to do is use this formula here. The variance of x is the expected value of x squared minus the expected value of x to be squared. Again, I can't emphasize enough that there is a very important distinction between the two. So we already know the expected value of x squared, and that's 3.6. But what we have to do is compute the expected value of x, e of x. So we're going to take the same approach here. It's straightforward enough this time after computing k. We have 2, 3, and 1. And the probabilities are 0.6, 0.1, and 0.3 respectively. What we're going to do is, for each of the three numbers, multiply the outcome by its probability. So 2 times 0.6, 3 times 0.1, and 1 times 0.3. That gives us 1.8. So that gives us is 1.2 plus 0.3 plus 0.3. Add them all up, we get 1.8. So the expected value of x is 1.8. So just to finish off, so we go back to this formula here earlier on that I mentioned earlier on. The variance of x equals 3.6 minus 1.8 squared. Okay, and multiplying that out, we get 3.6 minus 3.24, And working that out, we get a variance of 0.36. So 0.36 is our answer to part B. So k equals 1, the missing value is 1, and the variance is 0.36. And that ends our presentation.